Okay, so this video is the continuation of the solution of enrichment assignment 2. The subject is the divergence theorem and the curl theorem. Okay. Now, let us discuss problem number 6. Okay. First, let us write the curl theorem, Stokes curl theorem. What is there in the Stokes curl theorem? A dot dr integral over C is curl A dot ds, right? Clear? This Stokes curl theorem, it is also a general theorem for the vector fields and is obeyed for any vector A, is obeyed by any vector A. Clear? Now we want to write this curl theorem for xy plane. We want to write this curl theorem for xy plane. Okay. In xy plane, what is the radius vector or the position vector? R is I hat x plus j hat y. No z is there because it is in the xy plane. Clear? So dr is I dx plus j dy. Clear? Okay. And the area element in the xy plane will be given by ds is dx dy k hat. The area in the xy plane will be dx dy, the surface area, and it will be directed along the z axis. So k hat. Now I am putting this value in this equation. I am putting these values in this equation. Write it as A. In place of A, I can write I hat x, j hat ay plus k hat az. All the three components of A will be there in the xy plane because the components are the functions of the three coordinates x, y, z. Okay. So all the components in general, all the components survive in the xy plane. So A vector will be written as this. Now dr is I hat dx plus j hat dy. Clear? From here I am putting this value here. Equals curl A dot dx dy k hat. Fine. Everyone is convinced? Okay. Now I am erasing this part. Okay. We'll pause the video and write this part. Okay. So I'll get here, if I carry out the dot product, so I dot I survives and j dot j survives. So it will be ax dx plus ky dy equals curl A dx dy k hat. Clear? Now let us calculate curl A in the xy plane. It will be I j k del del x del del y del del z x ay az. So this will be I hat of del az del y minus del ay del z plus j hat of del x del z minus del az del x plus k hat of del ay del x minus del x del y. Now I shall put this value of curl A here. So I can write ax dx plus ay dy equals I hat del az del y del y del z plus j hat del x del z del az del x plus k hat del y del x del x del y dot dx dy k hat dx dy k hat. Clear? Clear? Okay. Now if I carry out this dot product, I dot k does not survive, j dot k does not survive, only k dot k survives. Okay, only k dot k survives, this term will survive. So I can write, erasing this thing, after this line I am writing it here. Ax dx plus ay dy is equals to integral over s del ay del x minus del x del y dx dy. Only k dot k term survives. K dot k is 1. Fine. Clear? Okay. So this is the Stokes-Curl theorem in the xy plane. Clear for everyone? This is known as Green's theorem. It's known as Green's theorem. So Green's theorem is nothing but Stokes' theorem in xy plane. Okay. Now in this equation, let me put Ax is y and Ay. Okay. ax is minus y and ay as x. So del ax del y will be del y of minus y, that is will be minus 1, and del y del x will be del x of x, that will be 1. Clear? So I am putting this value in this equation. What I will get? X dy minus y dx equals I will get this value is 1 and this value is minus 1. So 1 minus of minus 1 of dx dy. Fine. So I am erasing these lines. Shall get, after this line I am writing here, y dx will be integral over s 2 dx dy. Now 2 can be taken out of the integral over s dx dy. Now dx dy is the area element, a small area in the xy plane. If I integrate over it, I will get the total surface area in the xy plane, that is S. So this value is the total surface area S. Again I am repeating, dx dy is a small surface area element in the xy plane. If I integrate over all those small surface areas, if I add up, sum all those surface element areas in the xy plane, I will get the total surface area in the xy plane, that is S. Okay, clear? Which is enclosed by the contour C. Here, the surface S is enclosed by the contour C. Clear? Okay. So S is half x dy minus y dx. Okay, so S is the total surface area in the xy plane enclosed by the contour C. So S is half this expression, integral x dy minus y dx, integral over closed contour C, x dy minus y dx. So this is proved. Okay, so problem number 6 is over. Okay. Now let me erase it and come to problem number 7. What is there in problem number 7? Okay. Again, let me write the Stokes curl theorem. A dot dr is curl A dot ds. Clear? Fine. Okay. So now let us construct a vector. A is phi c, where phi is a scalar and c is a constant vector. So a scalar multiplied by constant vector will be a vector. Phi c is a vector, and when there is a vector, it must obey the Stokes-Curl theorem, a general theorem of the vector fields, right? So let me put pi c in place of a. You get pi c dot dr equals to curl of phi c dot ds. Clear? Okay. Now c is a constant vector and can be taken out of the integral. So c dot phi dr is, in place of this thing, curl of phi c, in place of curl of phi c, I'll put an expression given by the vector identity. What is that? Grad phi cross c plus phi curl c dot ds. Okay. Now this is a vector identity. Curl of phi c equals to this thing. Curl of phi c is given by this thing. This is a vector identity. Curl of phi c is grad phi cross c plus phi curl c. Okay, this is a vector identity, and this vector identity is given in problem number 8 in the first assignment. I am writing it here. Problem number 8 in assignment 1. Clear? You will see in problem number 8 in assignment 1 this vector identity. Clear up to this? Okay. Now let me erase this. So, c dot phi dr equals to. Now tell me, c is a constant vector. When c is a constant vector, its components cx, cy and cz is also constant, and curl c becomes 0, as we have seen in problem 4. In the assignment 2, when c is a constant vector, curl c is 0. Okay, so this part is 0, so we are left with this part only. Clear? So this part is grad phi cross c dot ds. Clear? Clear up to this? Okay, I am writing it here as c is constant vector, curl c is 0. See problem number 4 in assignment 2. In this assignment itself, in problem number 4, you will see this result. Clear? Okay. Now, we can put ds as in hat ds. Clear? Where in hat is the unit vector perpendicular to ds. ds vector could be written as in hat ds, magnitude multiplied by the unit vector. Yep. Learnt it how to write a surface vector. Clear? ds is in hat ds. Fine? Okay. So now again we shall use a vector identity. Grad phi cross c dot n hat. I can write it as n hat dot grad phi cross c. I can interchange the dot product without altering its value. I can interchange the dot product without altering its value. Clear? Okay. Now this thing can be written as C dot n hat cross grad phi. This can be written as C dot n hat cross grad phi. Clear? This is a vector identity. This is given in the vector identity number 3. Okay, in assignment 1. At the end of the assignment 1, there are 3 vector identities written. Identity number 3 is this. You will see and you will immediately understand this. How I have written this according to the vector identity. Clear? Okay. So, I can put this value here. I can put this value here from here to here. This value is this. Okay. So, I can write it C dot phi dr is equals C dot n hat cross grad phi ds. Clear up to this? Fine. Okay. So I am erasing this. Now, C dot phi dr is equals to, now C is a constant vector, can be taken out of the integral. C dot n hat cross grad phi ds. Clear? Now as this is true for any arbitrary non-zero constant vector C, এর একমাত্র possibility কি হতে পারে? This equals this. This equals this. Clear? So, as this is true for any arbitrary C, so the only possibility is phi dr is n hat cross grad phi ds. Clear? Now you can multiply the ds here. Phi dr d n hat ds cross grad phi. So phi dr is, this is ds vector, so ds cross grad phi, and hence proved. Okay, so this is how problem number 7 will be done. Fine.